Okay, so week 6, we're doing angles. The topics are, we're going to do complementary and supplementary. I think most of you should know that already. We're going to do some congruent angles, look at clocks, and then we're going to do a quizzes review. Quizzes is this, it's like a game type thing, and it's practice for the countdown round for the math counts. So as you know, in the math counts competition, there's a lot of different rounds. What you've been mostly working on is the sprint and target rounds where you can go slowly, relatively slowly. But in the countdown round, you got like less than a minute to do each problem. So this is very good for quizzes. This is the first week we're going to do with geometry. And we're going to do geometry for most of this class. So we're going to do geometry for quite a long time, okay? So let's get going. So first of all, complementary and supplementary angles. Before we go into what these are, you guys should know other types of angles, right? We have acute angle, which means less than 90 degrees, a right angle, which means 90 degrees, obtuse angle, which means greater than 90 degrees, okay? So those are the three main types of angles. But for complementary and supplementary angles, these are not words that we can use to describe one angle, right? We can't just say this angle is complementary. That doesn't work. We say two angles are complementary. So what does that mean? Two angles are complementary if they add to 90 degrees. Okay, so we say these two angles together, they are complementary when they add to 90 degrees. Okay, so if we just had a 20-degree angle, that wouldn't be complementary. A 20-degree and a 70-degree angle, those you would call them complementary angles. Similarly, supplementary, if they add to 180. Okay, so complementary add to 90, supplementary add to 180. Any questions? Cool. These two relatively easy problems. I'll give you 3 minutes for these. Get your answer, you can chat it to me. So for the first one, two angles are supplementary. One is 2 times the measure of the other. What's the difference in their measures? So for these types of problems, we're going to want to set up an equation because we don't want to just do it in our brain, right? So let's say one is 2 times the measure of the other. I could say that this one is x and the other one is 1/2 x, but that's not as easy to use as if I were to set the other one as x and this one as 2x. All right, first gonna omit someone. All right. I'm gonna set the other as x, the one, this one, 2 times x. So if they're supplementary, this means they add to 180 degrees. So 2x plus x equals 180. So for x, you can get x equals 60. So what's the difference in their measures? This means that the difference is going to be 2x minus x, which is just x, and x is 60. So that's the answer. Next one, two angles are complementary. One is 6 more than 3 times the other. What's the measure of the larger one? So this one, we actually do have to make an equation. We can't just do it in our brain. The last one, you could have done it, but this one, no way, right? So let's set the other as x. So this one is 6 more than 3 times x. So 3 times x, 6 more than that is plus 6. Okay, so we have 6 plus 3x and x. And these two angles are complementary, which means they add to 90 degrees. 6 plus 3x plus x equals 90. Solve for x. X is going to be 21. So if you find the measure of the larger angle, it's going to be 6 plus 3x, which is this. Okay? Any questions? Cool. Now we're going to go on to congruent angles. So what does congruent angles mean? Congruent means, we're going to see this word a lot in geometry, congruent means same, or like identical. In terms of angles, when angles are congruent, then this means they have the same degree measure. All right, so like a 10-degree angle is congruent to a 10-degree angle, okay? We're going to have congruent triangles later on, and congruent triangles, which would mean that these triangles are exactly the same. But in terms of angles, this just means that they have the same measure. Okay? So when can we find congruent angles? The most common type of congruent angle we find is when you have two lines and they intersect. Intersect means they cross each other. So as you can see here, these lines have made 4 angles. These 4 angles. Let's say this A, B, C, and D. Okay? You kind of guess which ones are congruent. Well, A and C are congruent. B and D are congruent. So we're going to label these like this. A is congruent to C. So this is the symbol we use for congruency. It is an equal sign with a squiggly line on top. So A is congruent to C. B is congruent to D. So these are what we call vertical angles. Not really vertical, but that's what they call it. Vertical angles are the angles formed when two lines cross. And we're going to say that A and C are vertical angles, B and D are vertical angles. This means that A and D, they're not vertical angles, because as you can see here, A and D, they're actually supplementary, right? Because they make a 180-degree angle. So this is how we'll prove that A is congruent to C. We know that A is supplementary to D. This means that A plus D is 180. But we can also see that D is supplementary to C, right? Because they make a straight line, which is 180 degrees. So C plus D is also 180. So you can see here that if we subtract D from both sides, we get A equals 180 minus B, C equals 180 minus D. So A must equal to C, and that's how you prove it, okay? So vertical angles are formed when two lines cross, and they form congruent angles on the opposite angles, right? It can't be A and B, they're not congruent, but A and C, they are congruent. All right? Any questions? That's the first common application of congruent angles. Then we've got a situation where, let's say we have two parallel lines. So parallel means that these lines are never going to cross. They're going in the same direction. And you could also call them having the same slope. Okay, they have the same like kind of like angle almost. So they have the same slope, which means that they will never ever cross. Well, obviously these two lines aren't making any angles, right? No matter how far we stretch, they're not going to make any angles. So if we draw a line that crosses through them, this is called a transversal. As we can see here, we've got some vertical angles here and some vertical angles here. So automatically, let's first label the angles. This is A, B, C, D, E, F, G, H. Okay. So obviously we know that D and B are vertical angles and A and C are vertical angles. So we already know that A is congruent to C, B is congruent to D. We also know that here we have vertical angles too. So we know that F is congruent to H, E is congruent to G. Okay. So now what? Is that all you have? Well, B is actually congruent to F. If you look at it, they look almost the same. And that's because these two lines right here, they're parallel. So if I were to bring this line up without changing its slope, then that's not going to change the angle it makes with the transversal. So if I move it all the way up, B is exactly the same as F. This means that A is exactly the same as E, D is exactly the same as H, G is exactly the same as C. But what this also means is that since G, like going back to here, since B is congruent to F, F is congruent to H, which means that B is also congruent to H. Okay? So we can see here that we have literally two types of angles here, two different measures of angles in this all out of all of these 8. So these are the acute angles and they're all congruent. And you have these are the obtuse angles and they are all congruent. Okay? So that's how we can find congruent angles in parallel lines. So if we have a transversal crossing through two parallel lines, we have 8 angles in total. 4 of them are going to be obtuse or whatever. They're going to be congruent to each other, and the other 4 are going to be congruent to each other. Okay, so sometimes you're just going to have to look at it and infer, oh, which ones are acute, and if they are, then they're going to be congruent. Okay, any questions? Cool. Let's do some problems. Give you, say 5 minutes. So for the first one, lines J and K are parallel, which means that the other line is a transversal, okay? So this means that if that was X, then this must also be X, right? Because they're both acute angles, so we're going to infer that they are the congruent ones, okay? So now we have X and X plus 30, they're going to make a straight angle. They're going to make a straight line. And this means that if we add them together, they're going to make 180 degrees, which means that they're supplementary. So X and X plus 30 are supplementary. So X plus X plus 30 is 180, and you're going to solve for X, you're going to get 75. All right. Next one, this is a very common problem. It involves like this hinge thing, okay? So the hint says we're going to draw a line, parallel line through angle B. So let's do that. I'm going to draw a line through angle B. Oh, that's not really good. Draw a line like this, okay? So now I've got three parallel lines, this, and this. So what does this mean? Well, if line A is parallel to line B, this means that line AB like this is a transversal, which means that this angle right here, that is congruent to 22. That's the same as 22 because they're both, what are they called? The acute angles made by the transversal through these two lines, right? Just this part. It might be a little hard to see, but it's only this part of the angle. Okay? Does everyone see how that works? That's 22 degrees right here. If we look at down here, B and C, line BC is a transversal cutting through them, which means that all the acute angles formed are going to be of measure x. So this is a measure x right here, because this is acute, this is also acute. But make sure that it's acute based on the line B, the line C, and the line going through them, okay? So we've got x and 22, and you can see how the angles x plus 22, if you merge them together, they make 71. So x plus 22 is going to equal to 71, which means x is 49. Any questions? This is a very, very common problem, so if you do have any questions, make sure you ask them now. All right. One more of these. You should know how to do these now, so I'm going to give you 2 minutes. No, maybe 3. I'll give you 3. Alright, so for this one, we're going to do the same exact strategy. Draw a parallel line through this. So we're going to see that, let me use a different color. This angle is congruent to this one. This angle is congruent to this one. Alright. So what is this angle? Well, we don't know what that is because all we have is that its supplement is 4x plus 6. So this means that this angle is 180 minus 4x plus 6. Make that in parentheses. Make sure you do that. So this angle is right here. If we add that to whatever the blue angle is, 2x minus 3, if we add this, the 2x minus 3, we're going to get 3x plus 1. Because the 3x plus 1 is like the union. Or like when we put them together, this is what we get. So if we add them, 180 minus 4x plus 6, added to 2x plus 3, 2x minus 3, we're going to get 3x plus 1. It's just an equation in x. We can just solve for x now. So x will get 35. Okay? Any questions? So again, the trick you need is to draw a line through the middle. And after you do that, everything should be more intuitive by that point. So now we're going to go on to clocks. Clocks are probably the most common problem dealing with angles in math counts, I'd say. So the clock problem. What is the clock problem? It's going to say, oh, the time is 7:20. What's the angle between the minute and hour hands? Let's draw a clock. Here we're going to have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so these are like notches. So we know that if it's 7:20, then the minute hand is going to be pointing at the 4. Minute hand is going to go like this. Okay. What about the hour hand? The hour hand doesn't go straight to 7 because at 7:20, the hour hand has moved a little bit and it's now in between 8 and 7, right? It's like in between right here. How much in between? Well, from 7 to 8, that's 60 minutes, right? The hour hand moves from 7 to 8 in 60 minutes. It starts at 7 o'clock. At 7 o'clock, the hour hand is pointing to the 7. But now we're at 7:20, which means that it's 1/3 of the way through. Because it takes 60 minutes to go all the way to 8. Now it's at 20 minutes. 20 over 60, that's 1/3. So it's 1/3 of the way to 8. So now we're going to use what I like to call these notches. Do you see how the angle created by each of these notches between the numbers is always the same? So in total, we have 12 notches, which means that in total they make 360 degrees, right? So 360 over 12 means each notch has 30 degrees. And this is something you should remember. Each notch on the clock is going to equal to 30 degrees. If we know this, we can just count the notches. We've got 1 notch, 2 notches, 3 notches, and then 1/3 of a notch. So we've got 3 notches here, which is 30 times 3, 90. And then we have to add 1/3 of a notch onto it. 1/3 of 30 is just 10. That's just going to be 100 degrees, okay? So this is a general clock problem. Any questions about this? So the biggest mistake people usually make is they point the 7, the hour hand directly at the 7, and they don't include this extra angle that it makes, okay? So that's something you should watch out for. We can also go in the other direction. Sometimes the question will say, oh, I have a question right here. It is between 7 and 8 o'clock. It's between 7 and 8. It could be like 7:20 or 7:50, okay? So we want to ask, when does the minute and hour hand make 180 degrees? When will the minute and hour hand make 180 degrees? Well, we know that at 7 o'clock, the minute hand is pointing straight up. The hour hand is pointing at the 7, right? So it will be a 7, 12. Okay? Well, obviously, this is not a 180 degrees, right? Well, we do know that we have kind of this big angle right here, and we're going to have to shrink it down to get to 180 degrees. We know that the minute hand moves faster than the hour hand. So at some point in time, the minute hand is going to catch up to the hour hand. The hour hand still moves, but not as fast. So the minute hand's gonna it's gonna catch up and it's going to make 180 degrees. So it's gonna be a little bit after 7 o'clock, right? So how does this work? Well, let's say that the time we're looking for is 7x. So x basically means like how many minutes is it past 7, right? If x was 3, then it would be 7:03, and that would be our time, right? So 7x. So at x minutes after 7 o'clock, we're going to say, oh, these angles are now straight angles. This angle is a straight angle, which means it's 180 degrees. So what does this mean? Well, right here at the initial point, how far are they separated from each other? Well, we've got 7 notches all the way to 7, which means that 7 times 30, we already got 210 degrees between them currently. Okay, so we want to get this down to 180. Well, how fast does a minute hand move? Well, every minute, how many degrees does it go past? Well, 60 minutes. In 60 minutes, the minute hand goes all the way around the clock, which means that it goes 360 degrees in 60 minutes, which means that's 6 degrees per minute. Okay? How fast does the hour hand move? The hour hand moves slower, right? It only moves 1 notch every 60 minutes. 1 notch every 60 minutes. We know that 1 notch is 30 degrees, so that's 30 degrees per 60 minutes, or 0.5 degrees every minute. Okay, so we know that the minute hand is going to move at 6 degrees, the hour hand is moving at 0.5 degrees. So what's the gap we have to close here, right? We're going to start at 210. The minute hand is going to have to catch up to the hour hand to close the gap to 180. So the gap we have to close is 210 minus 180. We have to close a gap of 30 degrees. All right. This is almost like, let's say we have 2 runners here. Initially, they're 210 apart. This guy is running faster than this guy, which means that eventually this guy's going to move forward, but this guy's going to move a little bit less. And eventually, they're going to be 180 degrees, right? So we want to catch up this distance. So we want to catch up a distance of 30. So what does this mean? Well, this guy is closing in at 6 degrees a minute, right? This guy is moving forward. He's running away at 0.5. So the distance that's closing between them is going to be 6 minus 0.5. Because if this guy wasn't moving, then it would just be 6. But since this guy is moving forward as well, then that makes it harder, right? So we're only closing in 5.5 degrees every minute. So if we're going to close in 30 degrees, and we're closing in 5.5 every minute, the amount of time it takes to close that 30 degrees is just going to be 30 over 5.5. And that's going to be the answer, okay? And that's going to be x. So if you were to calculate what that is, that would be, these kinds of problems are mostly going to be on the target round, which means you can use a calculator. So I have a calculator right here. We're going to do 30 divided by 5.5. X is going to be 5.45. So it's going to be around 705 this happens. All right. A little more than 705. Any questions? So for every kind of problem where you have to say, oh, at what time is this angle this? You're going to have to set up an equation or kind of use this. Or you could just memorize these values. All right. It's actually a lot easier. So you could just memorize, oh, the minute hand's going to move at 6 degrees a minute. The hour hand's going to move at 0.5. And all you have to do is calculate how much distance is there needed to catch up and what's the velocity between them that allows you to catch up that distance. We have 2 problems here. Actually, how about you skip the second one? This is one of those more difficult problems. But I'm going to put that on the homework. And if you do have any questions about how to do this, you could just refer back to the video, okay? Because I do want to get to the quizzes. So just do the first one for now. All right, so for the first one, well, it's kind of like the only one. Time is 4:31, find the angle. So first draw out a clock. Always draw out a clock. You cannot do this like in your mind, okay? So time is 4:30, which means that the minute hand's always going to be pointing straight down. So now about the hour hand. This is a 3, 4, 5, and then we got the 6 right here. 4:30 means that the hour hand started at 4, but it's now halfway between 4 and 5, right? Because 60 minutes in an hour, 30 minutes has passed, which means that it's halfway through the notch. It's going to be like right here. Okay? So it's halfway through the notch, which means that the distance here we have 1 notch from 6 to 5 plus half a notch. So 1 notch is 30. If we add half a notch onto that, that's going to be 15. That's going to be 45 degrees. Okay? Any questions about that? So it's always important to draw out a diagram. And then the numbers are not always nice like this, okay? Sometimes you're going to have to deal with more mean numbers, more difficult numbers. So you don't really have to rely on the fact that this is halfway through. You have to rely on the fact that it's 30 over 60 through. Say this was 46. Say it was 446. If it was 446, then we would say, oh, it's 46 over 50, 46 over 60 of the way to 5, right? We have to use the fraction. You can't always rely on the fact that this is just intuitively halfway through, right? You have to think about the fractions, and sometimes the numbers are not going to be as familiar. So we're going to do a quizzes now. Do not leave the Zoom. So I'm going to share my screen with the quizzes on it. Here it is. Here's the quizzes. We have a Mathcounts review quizzes. It's got 10 problems, I'd say. It is a review of everything we've learned up to here. And yeah, so every problem you're going to have like 1 minute, I'd say. And they're all free response, which means that you're going to type in an answer. It's not going to be multiple choice. So most quizzes you might have done are going to be multiple choice, but this one is not, because in the countdown round, nothing is multiple choice. In the countdown round, you have to give your answer. You have to say it out loud. There's nothing for you to select on. So these are going to be free response questions. Okay. Let's get started here. You can go to quizzes.com and type in the code, or there's a direct link here I can give you. There's a direct link to the quizzes. If you click on that, you will be sent to the quizzes automatically. We should have around 10 people at the end, if everyone's participating. Waiting for 2 more, and then we'll get started. So I think I might have to end the Zoom a little early, but if I do end the Zoom, keep going on the quizzes, because yeah. So I might end the Zoom early, so don't worry about that if that happens, okay? Is anyone not in yet? I don't think so. Okay, let's get started.